Hi, thanks for coming for the talk. I'm going to talk about interpreting relational schemas into Neo4j, but before I begin, a bit about myself. I'm Praveena. I work as a software engineer at Neo in London. I'll be available for questions later, so if you have anything to talk about, we can chat after the talk. So I wanted to, so a year back, Neo4j started working on the Neo4j ETL pipeline. The motivation behind the project was that we wanted to cater to developers who want to empower their solutions using graph databases, but you also want to go for a long-term solution, not just something that you can adopt and use it as your primary database, but also as things that you would use in an ETL pipeline in different business processing tools. So that's why we started with the Neo4j ETL project. And before I could talk to you a bit more about the project, I thought it will be useful to cover some of the reasons and drive behind why Neo4j is a better choice for your solutions over relational database. So first thing that I wanted to talk about is why Neo4j, why would you want to choose Neo4j over relational database? As you need a database, you typically use a database to store data and look it up, and you want to find a database that is efficient in both these operations. If you think about storing data in a relational database, in tables and as tables and relationships, then you would know that you would have to store it using keys and constraints and inside tables, and you would know what kind of problems it has in terms of looking up the data later, because unlike Neo4j, in relational databases, your relationships aren't first-class objects. In Neo4j, you can query for your data directly in nodes. You still can't query relationships directly, but it's easier to look up the connected data in Neo4j compared to what it is in your regular store-bought relational database. An example to illustrate the point is if you think about a typical use case scenario where you want to represent a person belonging to different departments. In a relational database, you would have a persons table, and you would have department table, and you would have a department members join table, which maintain the relationship between Alice and the departments that she belongs to. So you can, okay, I'm not able to point, but anyways, you can see that Alice has an ID of 815, and that is being stored in the department members join table, linking to the department primary key IDs, which is like 111 and 119. So if you were to find out which departments Alice belongs to, you would first have to query the ID of Alice in the persons table, then join on the join table department members, find the ID of departments, and then query the department table. So that's how you would typically write a SQL query. So all you care about is the relationship between these three tables. If you were to represent that same thing in Neo4j, you would have a node person, node with the label person for Alice, and you have the three departments that are there, and you would just basically point the departments that Alice belongs to using your relationships between those nodes. So the concept of having a join table is no longer there in a relational database, because what you have directly is the connected data. You don't need a table to maintain the connections. Your relationships are already there in the database. So this is a much more simpler way to express the same thing, which is Alice belongs to these two departments. If you compare it side by side, if you're used to a relational database, you can see how easily it translates to a graph database like Neo4j. The second thing that I alluded in the previous point was that Neo4j is whiteboard friendly. If you were to explain this domain to your colleagues when like someone joins your team or something like that, you would go to the whiteboard and you would draw Alice is there and Alice belongs to 2 different departments, you wouldn't possibly draw the join table in between to express the same sentiment. And in Neo4j, you save the data exactly how you would represent it in the whiteboard, which also helps you to add different schema components to it later part in the design of your solution, rather than having a completely formalized schema that you would expect in relational databases. In the book, Mastering Data Modeling, they talk about three different models when you translate a domain problem into database. How would that be reflected? So they talk about conceptual, logical, and relational models. And the main thing that they talk about in your conceptual model is where you express the different entities and attributes on the project. For instance, Alice as a person is an entity, and the name Alice is an attribute on the entity. And so you would have like these different entities and how they are related, and how the relationships are expressed between those entities is what you would express as a conceptual model, typically on a whiteboard. And then when you try and adopt the conceptual model to your solution in the logical space, you would come up with, okay, we will have a table for Alice, we will have a table for department, and we will have a join table in between. And these are the columns, different columns between those tables. And finally, when it gets stored in the disk, you have the physical model, which is like you think about indexes, table spaces, how it has been partitioned, and things like that. There is an interesting talk called Data Modelers Still Have Jobs Adjusting for the NoSQL Environment, where Joe McGuire talks about how the database administrations, like all the tuning and stuff like that people were doing before in RDBMS, it's not that the job is non-existent. It has been translated into the NoSQL world, and he talks in depth about how the 2 different approaches vary. So in what he says is that in relational database, the the conceptual and the logical model gets muddled into your relational databases as the relational model. So what you have is your entities are expressed in terms of tables, your attributes are expressed in terms of columns, relationships as foreign keys, and identifiers as foreign keys and primary keys as well. And your physical model stays the same. So what you're actually seeing is the tension between how your whiteboard friendly, your conceptual model gets translated to the logical model, which is what you would program in your solution. And in Neo4j, these lend itself easily, where you have your entities as nodes and labels, and your attributes as properties, and relationships are relationships themselves, and identifiers are used based on the constraints, the unique key constraints. So having Neo4j as a whiteboard friendly domain, it helps you to break the barrier between your conceptual and the logical model. So if I were to model Praveena works at Neo4j, I would draw this in the whiteboard as I have a node, I have a person Praveena, and this person works at Neo4j. And if I were to use it directly in Neo4j, I would just go draw the exact same relationship in the database as well. So in MySQL, let's look at the different types of modeling you would do in a relational database, for example, MySQL, and how you would do it in Neo4j. In MySQL, if you have a person who lives at a certain address, you would have a person table. For the sake of simplicity, let's assume that the address ID is actually on the person table itself. And you have the address ID. So you have the foreign key of the address ID being linked in the person table itself, and you basically look up based on that. And in Neo4j, you would just say person lives at this address. And if you have more people living in the same address, you just add the relationship between these other different nodes. In terms of the join table scenario that we saw earlier, if you have a course and you have a list of courses and you have a list of students and the students take different courses, you would use a join table to express the same sentiment. In Neo4j, you would eradicate the join table, and what you would use instead is just the relationship between those two nodes. This is interesting because when you come, in the case of a shopping cart scenario, you usually have a lot of different domains, but ultimately it needs a reference when you try and place an order. For example, when you place the order, you might need who is making this order, who has approved this order, where is this being shipped to, what is the procurement information, and things like that. And as developers, you would know that there is this one small DTO object that gets passed around in different services. And ultimately, you'll end up persisting that DTO object as well, which gets read from the service, and then it gets written back as a service when the order gets updated. So in Neo4j, we express that sort of a node as an intermediate node. So in this case, orders is your intermediate node where it contains the information about the customers, order details, and all other shipping information and employee information. And you would represent the same thing as an intermediate node with the label order in Neo4j. It's important to note that Neo4j is schema optional, unlike other NoSQL databases out there. The reason behind that is when you look at when you land in a city, for instance, you need some sort of structure to understand, to guide you through the data that is available to you. So as humans, as processes, just like humans, processes need the blueprint of how to manipulate states of the objects and things like that. So if anything like right from recipes to navigating a city and things like that, you always need structure for you to go from one place to another. And similarly, when you're adopting a database for your solution, you need some sort of structure to identify, to query when you're building your solution. So Neo4j is what we call a schema-optional database. In Neo4j, you have nodes, labels, properties, and relationships, which you could use to query your data, to look up the data, similar to how you would have your tables, primary keys, and foreign keys. But because it's schema-optional, it's easier to change your model as your solution gets developed, like at different times in your development phase and different times depending on your feedback cycle, you would want to change how the schema of the database is, and at that time you wouldn't have to write down DB migrate statements because your schema isn't your schema is persisted, but it's not strict as how it is in RDBMS. So in this case, if you were to look for Alice who works at department for future, you would just write a query where you would say, find me nodes with the label person and the property name Alice, who has this relationship belongs to, with a department node with the name for future. That's how you would write your query, which is very similar to writing a SQL query. So if you're excited about Neo4j, but you want to start working with Neo4j now, and you have already data lying around that you would like to import into Neo4j and play around with it, we have a bunch of tools, and I'll be demoing Neo4j ETL, which is the tool that we had developed to interpret schema as graphs and do the import as well. Currently, we have tested it with MySQL, Postgres, and Oracle. So if you have one of these databases and you want to look at how your ER diagram in some sense would look in a graph database, you could go ahead, download Neo4j ETL and have a look at it. And if you do find bugs, please let us know. So I'm going to do, what I'm going to do is the infamous Northwind database that comes shipped with every RDBMS out there. So this is the ER diagram that I generated using MySQL Workbench. And it's just the ER diagram of Northwind database. And I want to convert this into the Neo4j schema. So this is how you would express the Northwind database in Neo4j. And I have done that using no manipulation myself. It's just using the Neo4j ETL tool. So it would be a good starter if you were to go and have a like a nose around and see how it is. So all this using just one command. So let me go ahead and do the demo. Do I have time? Yes. So is this visible? Yep. Okay. Just so you guys know, I'm not cheating. So I've got match of n, return n, no data, okay? Match of n, return n is like your select all statement, select all from all tables. Just so if you're not familiar with Cypher query, that's the query that I have executed to get me all the nodes and return me all the nodes. Okay, so first things first, let me stop Neo4j. I've done this demo twice before. It works 50% of the time, every time. But you know how nerve-wracking it can be doing a demo in front of a bunch of developers. God, they're the worst. Okay, anyway, so I've stopped Neo4j now. Let me just check whether that has happened. Good. And I'm executing my Neo4j ETL command. I'll walk you through what this command does shortly. But for now, just like be prepared to be awed. That's all I can say. Is that a word, awed? I don't know. Anyway, so what we can see right now is I've executed this fancy command. It's creating MySQL to CSV mappings, and it's using the CSV002 directory to generate the CSVs there. And it basically wrote a bunch of data into those CSVs, and it's done. It has finished what it was supposed to do. And I'm going to start Neo4j. Neo4j has started, and I'm going to whoa. I'm very chuffed with myself, but yeah. But yeah, there you go. So what happened right now is it exported the Northwind database into Neo4j. And we'll see how that came about shortly. So I want to, wait. Okay, so what you saw is importing data from MySQL database as nodes into Neo, and you imported relationships represented as, so it was joins in MySQL that I have imported as relationships into Neo4j. So this is the anatomy of the export command. You have Neo4j ETL, and I'm specifying which database I want to export it from, and I'm giving the username and password of my Neo4j database. And I'm saying that this is the destination directory, and I'm giving it an import tool. So if you're familiar with Neo4j, the bunch of tools it comes with, Neo4j import is one of the tools that this ETL pipeline is using, ETL tool is using. And Neo4j import is something that you can use right away. If you have CSVs that represent nodes and relationships, you can just use the Neo4j import to just go ahead and import it. But anyway, so you have the export, and you give all the credentials, and you tell, put my data into this database directory. So let's look at what we did step by step. So there are three things. Okay. So first, if you were to look at the arrow mark, it says interpret schema to tables, joins, and join tables. So the first thing is like you from the MySQL we use a database inspector, and it says that it queries the metadata in the MySQL database and says, all right, I've done this job. You have these are the tables, these are the relationship between those tables, and these relationships are represented as the specific joins and the specific join tables. So you first get that metadata information and you translate it into a JSON file. This is your artifact, which says that in MySQL world, which has been expressed in tables, joins, and join tables, has been represented as nodes and relationships. This is how you can do it. And we take the mappings.json file and we use a mappings extractor which basically queries the SQL in the JSON file to query each of the tables and get those as nodes and relationships. It creates the CSV files in the second step. And the third step is the Neo4j import tool uses these CSVs, which is the nodes and relationship CSVs, and imports it into Neo4j. So the first thing to discuss is how does the schema interpretation work. So in MySQL or in a relational database, the first rule that we use is if there's a table with a foreign key in it, then and it is interpreted as a join. So the parent table is imported as a node, and the relationship between that node and the other node is imported as a relationship. So you had the person table and the address table, and the address ID was the foreign key in the person table. So the first rule that we used is, in this case, you would import it as a person node, address node, and the join is expressed as a relationship. The second thing is the student course. So what we come up with is a table which is similar to the student course table, has two foreign keys and no other primary key. Then it is imported as a relationship. So it completely eradicates the student course table, and other properties, other columns on the student course table, such as credit, will be persisted as a property on the relationship. So in this relationship, for instance, if I had Praveena, who is a student of computer science, and my credit is, let's say, 7 out of 10, then I would have the credits persisted on the student course relationship. That's a very important thing in Neo4j. Like, your properties are not just on the nodes, it's also on the relationships, which kind of help you to migrate at a later stage if you realize that, oh, the student course is becoming like an intermediate node with a lot of other information in it. Then in that case, you would just simply remodel your Neo4j database when you reach that point to create an intermediate node to represent that relationship. And the third thing that we discussed is similar to what, like, orders by itself doesn't have much of a value. All it does is it links to a bunch of other tables here. For instance, it has all the IDs in the orders table are just relationships to other tables in the MySQL database. So in this case, we have imported all of that as an intermediate node, where you express the relationship between the intermediate node to the other nodes. This gets returned into the mapping file. So we say that, okay, you have a graph object type node and the name is book there. And it also gives you a SQL statement of how you can select all the data in the node and how you could write it as a node in Neo4j. So basically we have a blueprint of what the node should look like from when you import it from MySQL database. And this gets used when you're trying to write the nodes and relationship CSV. So what you could do is you could just create the mappings.json using the inspect schema command, the generate metadata command. And that would allow you to look at the mappings.json file, and it will let you edit that as well. So the ETL tool allows you to give your own mappings file if you have one. So we use the SQL to import it into nodes and relationships CSV. And then we use the Neo4j import command, which just goes ahead and looks at all the list of nodes and just uses those nodes as CSVs and then the relationships between them. So this is a tool by itself. The Neo4j import is a tool by itself, and there are a lot of guides and tutorials available if you would like to play around with it. And this is how your migrated DB looks like. The tools that we had used in ETL is just a plain JDBC driver and Neo4j import. Both of those are open source. Neo4j loves open source, and it's also designed, ETL is designed for extension. So if you want to play around with visualizations and things like that on top of your MySQL database or your Neo4j database, we have hooks in the first part of the command, which is where you just do the inspect schema, and the JSON file is written. You can play with like different visualizations tools there. And also when you do the generate CSV as well. I was told to talk about a few of the other things that we have in the surface of Neo4j for adopters if you want to give Neo4j a go. If you had been to any of our trainings, load CSV is extensively used there, wherein from the browser you can load the CSV directly. Like it takes file over a file protocol or FTP, anything, like you can just give it an HTTP URL and you can load a CSV directly from the browser using the load CSV command. And you also have APOC procedures and of course Neo4j import and Neo4j admin as well, where you can dump and load and things like that. In conclusion, I want to tell, if anything, I want you to go home with this idea. Like, I mean, everywhere around us we have predefined structure, and most of the applications that we build start off with having predefined structures. But then slowly we see anomalies emerging here and there, and your schema and the database that you are using should be easily extensible for you to make those changes and support those anomalies. And one thing Neo4j does really well is it helps you to adapt predefined structures and rules and also be forgiving when those rules don't apply. So if you have anomalies outside your database schema, Neo4j database lets you adopt that and like have specific functionalities for those kind of things. Go ahead and give Neo4j a go, download it, and please do let us know how you like it. These are a bunch of links that I came up with where if you want to see how ETL works and like inner workings of those. And of course, like all of these are open source, so if you have a GitHub account, even if you don't, it's fine, like go ahead and check it out. That's it. Oh, sure. Pause. It's just a minute. That's my Twitter handle. I have very low self-esteem, so please be nice.